In this session, we are going to discuss about the practical or experiment, which is going to measure the thermal conductivity of solid metallic rod or slab. So some experimental setup are having rods, some are having slabs. So the main aim is to calculate or to measure the thermal conductivity of solid material. Now we know what exactly the thermal conductivity is. It is the property of material which clearly showing how much heat is going to flow in that material. So depending on that values of the thermal conductivity, we can call the metals as a good conductor or bad conductor or insulators. So we should know what exactly the thermal conductivity is and what are the values of thermal conductivity for the respective material. Now, for this practical or from the practical point of view, we have to measure or we have to calculate the thermal conductivity on the basis of Fourier's law. So the Fourier's law mathematically is Q equal to minus Ka dt by dx dr, or whatever the path of that heat is. So for this rod or slab, so that is Q equal to minus Ka dt by dx. So K is the thermal conductivity, A is the area of heat transfer, dt is the temperature difference, dx is the distance or the thickness of heat transfer, and Q is the rate of heat flow. So for calculating or for measuring the values of K, we must know the values of Q, A, dt and dx. So on the basis of other values, we can calculate or measure the value of K. The POs, that is program outcomes for this experiment is, that is the basic knowledge. We have to apply the basic mathematical calculations, science and some engineering skills as per as the chemical engineerings are involved. Then we have to apply the discipline knowledge from the chemical engineering point of view, and we have to perform the task which is related to that experiment. Competency and practical skills, that is use the heat transfer principles to increase the efficiency of the apparatus to save the energy in chemical process plant. So for the calculation for measurement of this thermal conductivity, we have to measure the temperatures from various points of the rods or the slabs, and for that purpose we have to measure the temperature from the thermocouples. Then we have to apply the heat, that is why the voltmeter and ammeters are also required. Relevant course outcome is to calculate the rate of heat transfer by conductions, because after calculation of Q only we can calculate or measure the value of thermal conductivity. Then the practical outcome, use the thermal conductivity equipment consisting of solid metallic rod or slab to calculate the thermal conductivity. So the main aim is, or the practical outcome is, to measure or to use or to calculate the thermal conductivity with the help of given apparatus. Relevant affective domain, related outcomes are follow the safe practices while working on the experimental setup, then maintain the tools and equipments before starting the actual practical. So we have to check the voltage supply, current and the temperatures of respective thermocouples. Then minimum theoretical background, what we know that is nothing but the Fourier's law. So we must have the knowledge about this Fourier's law. So I have already discussed what exactly the Fourier's law is. It is Q equal to minus Ka dt by dx, where K is the thermal conductivity, A is the area of heat transfer in meter square, dt is the temperature difference in Kelvin, and dx is the thickness or the path or the distance of heat transfer in terms of meter. Then Q is the rate of heat transfer in terms of watt, that is joules per second. So this is the practical setup. So that may be a rod, that may be a slab. So for calculating this thermal conductivity of this rod or slab, we must incorporate the thermocouples on the various places or the locations. So here we can measure the temperature from this point, then the second temperature, then the third temperature and the fourth temperature. So we have to supply this water to measure the temperatures of these T3 and T4, or we can have the idea from the inlet and outlet temperatures of the water how much heat is gained by the thermal metals or the whatever the metal is there, that may be a rod or slab, and for heating purpose we can supply the steam or we can supply the electrical supply for having the heat, right? So this is the x, that it may be a thickness or the length or the distance or the path of the heat exchanger. Then this may be an experimental setup where you can having the idea regarding this control panel, that is dimmer stat, for increasing or decreasing the voltage, and simultaneously the current is also going to change. Then for heater, the knob is there, so we can operate this knob and heater can be on or off. Then this is the main supply indicator. These are the indicators of voltage and current and temperatures. So depending on the set point, whatever the requirement of from our side, we have to adjust this voltage, and then we can have the different temperatures on the control panel display. So this is the simple assembly or the experimental setup where you can have the idea regarding this thermal conductivity measurement. The resources required for this experiment is thermal conductivity of metal rod setup as per the standard specification, metal rod or metal slab having some diameters and length, and 4 thermocouples at least for measuring the different temperatures on that rod. If slab is there, then the thermocouple may be 6. Then precautions to be followed. Reading should be taken at steady state only. So in all the experiment, we know that after reaching the steady state temperature only, we can have the actual readings or the accurate readings. The power should not exceed the maximum limit. So whatever the set point we have set, that is the voltage as well as the temperature expected. According to that voltage and temperature only, we have to check the power supply. Then the procedure, start the water supply to the systems, because before heater we have to supply this water for gaining the heat, otherwise this heater can be damaged without the water. So first step is to start the water supply to the system, then start the heater and set dimmer, that is dimmer stat, such a way that it will give approximate 100 voltage of reading. So that is depending on the requirement of your experiment, you can change the voltage. Note down the voltage and current, that is in ampere, from the digital display. After attaining the steady state temperature, normally it requires at least 1 to 2 hours. Note down the temperatures of the thermocouples. So we can have the readings, that is T1, T2, T3 and T4 if it is a rod, and having T5 and T6 additionally if you are having the slab in the setup. Gradually increase power by increasing the values of V and A. So if you increase the values of voltage, simultaneously the ampere or the current is also going to increase, and we can have the different readings of temperatures. So take 8 sets of readings Heat loss through the apparatus are negligible since the surface is well insulated. So normally on the all the apparatus are having good insulators, that is the thermal insulators, which are going to minimize the heat losses to the atmosphere. So we are considering the negligible heat losses in the atmosphere, and on that basis we are having the different temperature readings. So this is the simple procedure for running this experimental setup. The resources required. So whatever the resources you have, now in our case we are having the KC company's setups and we are having the slab instead of rod. So likewise, whatever the experimental setup and that company make is available with you, that should be written in this 12th point. Then whatever the actual procedure is followed by the staff and student, that should be written here in the 13th point. The precautions we have already discussed, the precautionary measures actual followed by the student and staff should be written here, and then observations and calculations. So if there is a rod, then the diameter of rod, if length of rod for the rods, and if it is a slab, then the different dimensions of the slab should be written in terms of centimeter and in meters. Then in the observation table, the voltage readings are required, current is required, then we can calculate the Q supplied, that is whatever the heat supplied in terms of power. So that is voltage into ampere. Then temperatures, T1 temperature, T2, T3 and T4 temperatures, and we can have the temperature difference, that is T1 to T4, that is the overall temperature difference. Why it is required? Because the Fourier law says that Q equal to Ka delta T by dx, and we have to calculate this K, so that equation can be rearranged like this. So this dx can be replaced as length because the heat is exchanging along the length. So in this case, if it is rod, then K can be calculated with the help of this formula, that is small k equal to Q into L upon A delta T. So Q is supplied voltage and ampere, the length, that is fixed dimension, then area we can calculate depending on the rod dimension and or the slab dimension, and temperature difference from the observation tables, that is from the digital display, right? So in the calculations, area can be calculated with the help of formula pi by 4 d square if it is rod. Then Q can be calculated with the help of voltage supplied and current appeared, that is V into I. Then temperature drop, that is delta T. Overall temperature drop is T1 minus T4. And with the help of these above 1, 2, 3 calculations, we can calculate the thermal conductivity of the rod or slab. So please take care about the units of all the parameters, that is of Q, L, A and delta T. On the basis of that only the unit of thermal conductivity can be decided, and whatever the calculations are there, so that should be written with the units in the results. Then we can interpret the results and we can conclude from the results that thermal conductivity of this metal rod or slab is this much, the expected or the standard thermal conductivity of this metal rod or slab is this much, and why these thermal conductivities differ, you can conclude and interpret these results in these points, that is 17th and 18th point. So whatever the procedure we have followed, whatever the observation calculations we have done, we can check the learnings of this experimental setup from the different questions, like give the unit of thermal conductivity in SI unit, then identify the MOC of metal rod, that is material of construction, obtain the value of thermal conductivity of 5 metals from the literature, define steady state and unsteady state conduction, etc. Right? So we can have the cross check of the learning outcomes of this experimental setup. Thank you. Now we can go for the actual experimental setup and have the demonstration. This is the actual experimental setup of the thermal conductivity of insulating slab. So in the theoretical part, we have discussed about these calculations and the objective of this practical. The thermal conductivity is the main objective, and for thermal conductivity, we must have the values of Q, A, dt and dx. So this is the compartment where the insulating slab is there. It is 100% insulated, and that is why we can consider the heat losses as a negligible. Now in the control panel, you can observe the displays, that is the voltmeter display and current display. So voltmeter displays the voltage supply and ampere meter displays the current supply. Then the dimmer stats are available. So one dimmer stat is for central heater and another dimmer stat is for ring guard heater. So we can increase or decrease the voltage with the help of this dimmer stat for central heater as well as for the ring guard heaters. Then this is the digital temperature indicator or display where we can observe the different temperature readings. These are the knobs to adjust the heatings of central heater as well as ring guard heaters. Now this knob is towards ring guard heater. So from that knob we can understand the temperatures are respective of these ring guard heaters. This is the main display indicator and this knob is for the heater, right? So we can have the different readings from this experimental setup. So this is just now, this is the 47 or 48 is the voltage. Now in this ampere is 0.64 approximately. Then you can have the readings, that is 103 temperature, then 68.3, 73.1, then third temperature 3 is 61.7, then 67, 54.3, 28.7, etc. So we can have the different temperature readings of various locations in the thermal slab. If it is the rod, then we are having only 4 temperatures, but for slabs there are 6 temperatures. So after observing these different temperatures and after note down the different temperatures as well as voltage and ampere, we can calculate the Q, that is with the help of formula V into I. So currently we are having something 48 voltage and 0.66. So we can multiply these values and we will have the value of Q. And with the help of these temperatures, we will have the delta T, that is temperature difference, and with the help of the dimensions, that is fixed dimensions, we can calculate the area of heat transfer, and with the help of the formula we can calculate the thermal conductivity, which is the main aim of this practical or experiment.